Good morning everyone, and welcome to Unlocking Java's Code session. I'm sure that most of you are wondering what it is in this session based on the title. I will shortly tell you more about it. But before that, let me present myself. I'm Mihaela. I'm a university teacher at the Faculty of Cybernetics and Informatics in Bucharest, and also a software architect at Systematic, a Danish company specialized in building software for critical domains, like we like to call them, such as defense, the department for which I'm also working, but we also have healthcare and many others. Hope you all had your coffee ready this morning, because we are about to kick off a second exciting day here at Spring I/O Conference. And today we will start with plenty of Java coding challenges. So this is what it is about with my session. We will have a lot of Java coding challenges. And afterwards, we'll continue to enjoy a session full of day of discoveries and more learnings. So think of Java programming as a vast, intricate maze, which is filled with both obstacles but hidden treasures as well. And in the next 45-50 minutes, I hope that we can explore some of this maze together, a very small part of it at least. And today's session is meant to be a blend of active exploration and active participation from your side, because it is being focused mainly on practical exercises. So what we see here in this agenda is the only item that we have today. We will hopefully have some fun with Java coding challenges. And these exercises, these coding challenges that I'm telling you about, are crafted to challenge in both identifying what a specific code does, or what needs to be changed in order to improve it, either from a performance point of view or just to identify what that piece of code does. And let's see at least what Java topics are we covering today. So we will showcase some examples for Java collections, plenty of stream exercises, but we will also look at some of the newer Java functionalities that were introduced in newer versions, such as record or seal classes. We will handle some Java puzzles for concurrency, but also some optional exercises and many others. There are 20 exercises. I hope we can finish all of them, because at the end we can also see the leadership board of what you have answered in there. And I will explain a bit how it is structured, the presentation. So first of all, we will look at a specific piece of code for which we will ask either to identify what it does or what needs to be changed in order to improve it. So we will have a look at the code. We will also get some possible options to select from. Only one is correct or not particularly correct, but most complete or complete compared to others, especially when we deal with those optimization challenges, because there are multiple ways to improve a specific piece of code, but one is, at least from my perspective as I did the exercises, is more accurate than the others in order to either improve from a performance point of view or just to make that code more concise and more readable. Besides looking at the code and the options, you'll get this QR code now. It's available for all the other exercises, so it's enough to scan it now and that's it. Afterwards, I will be the one that activates the question and move to the next one. At the end of each exercise, when you finish submitting your answers on what you think the correct answer is, we will review what was correct, what was the correct answer and why. And also we will have a look at the other options to see why they weren't correct or why they shouldn't have been selected in that case. So, is everyone ready, or someone needs more time to scan it? Raise your hand if you're still logging in. Okay, let's wait for a few more seconds. So I think I see that 32 people already joined, so let's wait a few more seconds. In case the QR code doesn't work, you can use slido.com, and you have there the meeting number 3509467. So that's another option to connect as well. All right, so I'm asking again, is everyone ready now? Yeah. Okay, perfect. Then let's dive right in. because we will start with a warming up exercise. So this is something simple, and I hope you can see it behind. At least I see some lights on the screen. So it's everything okay?
Can you turn off the lights maybe?
Let's see if the organizers can help us with this and turn off that light from the left of the room. Is it possible? No? Okay, sorry. Not sure what to do in that specific case. Maybe we can move to the front of the room? Or I don't know. Maybe we can still find some options to turn off that light.
Maybe the switch is over there? No?
There are a lot of places in the first row. So I see you can, some of you moved. All right. So it's everything okay now with the setup? Okay. Okay, some organizational details. At least I can start telling you about this exercise before I can activate the answers for it and you to submit it. So this example deals with static variable initialization, where the order of the initialization matters, because in some specific situation it may lead to unexpected results. So it is important to know how it works. And there we have multiple static initializations. So I will activate this first exercise so that we can get used to the system. And you can actually submit the response now. And there's only 20 seconds for this. It's a simple exercise, a warming up to get used with everything. And let's see. There are all the options being selected at the moment. Only one is correct. And in a few seconds, we will see which one was the correct one. So the time's up. And the response was B, 20. And I see that the majority, 39% of you answered correctly. So let's see why. You have the correct response now displayed on the phone as well. So how static blocks works? They are executed in the order they appear in the code. And as you can see there, first of all, we have a value assigned to 10. But afterwards, the subsequent call comes and sets that value to 20. And actually, in this example, the declaration that comes last is the one that replaces the previous version. So the correct output in this case is 20, showing that the final static initialization takes precedence. So the last value that is being assigned, that is the one being used. And actually here we can see that the first value is not highlighted in the IntelliJ that I have used in my IDE. So that could have been a tip to select the correct answer as well. All right, let's move to the second exercise, still warming up in the same area. Afterwards, we will start increasing the difficulty. And the second exercise, it starts from a simple list of strings that we have there, some fruits. And we are performing some operations based on the stream obtained from that list. We are actually trying to check for vowels. And I'm not going to say exactly what that method does. I will actually let you identify. And I will start the timer now so you can start submitting the answers. And let's see, what do you think the displayed output would be in this case? There is a twist in what that method, check vowels, actually does. It uses some regular expression over there. So what do you think it does? What do you think the correct output would be out of those 4 options? Does it select all the words that contain vowels, or just those that starts or ends with a vowel? What do you think? We have less than 10 seconds to identify. And in about 3 seconds, we will see what was the correct answer. And I guess time's up. And the right answer is D. And most of you answered correctly. In this exercise, we were supposed, first of all, to see what that partitioning by function does. It is in the Stream API for a very long time, though. It's, if I remember correctly, even from Java 8. And this is used with a custom method, the one that I mentioned about, check vowel. in order to determine if a string starts with a vowel. So here it was important to observe how it was created. So those of you that answered D, well done. You spotted what my regular function does over there. All right, let's move to a first optimization challenging exercise. And I hope you will have some fun with this one. We still start from a list of string. I haven't added the method, but the first one, generate random words, just generates 10K string words. I haven't added the code for that as it wasn't relevant for this specific code. But we are trying to group by first letter those 10,000 words, string words that I have in my exercise. And the question is, what would you change in this specific piece of code in order to improve it? And as options, before I activate the possibility of you to submit the answers, I will read them for you. So first of all, we can replace them with a traditional for loop. We can replace the traditional for loop with a parallel stream for better optimization. Second option would be to use custom collector instead of grouping by collector for more flexibility. The third option would be to use some lambda expression and encapsulate the entire logic in there to promote functional programming, for example. Or the last option mentions that just to keep the code as it is optimal. And I will trigger the possibility of you to submit your answer. And let's see what do you think about this. So out of those four options, how would you optimize this specific piece of code that groups words based on their first letter? And as options, to use parallel streams, to replace with a custom collector, use lambda expression, or leave the code as it is. And already left 20 seconds left. Okay. It seems that you are in between parallel loops and lambda expression. So let's see which one will win at the end. Some of you also wouldn't change the code. Seems optimal. It does its job. So if we are to run this code, it displays correctly. It groups the words by their first letter. Oh, and the time's up, and 50% of you answered A, which is actually the right answer. So we can use parallel streams to improve that code, especially as I had there, I start from the beginning with 10,000 words. If I were to have 5-6 strings in my list, it wouldn't have mattered if I would have used parallel streams. It could even decrease the performance of our code. But with 10,000 and even more, then it's worth having some parallel streams. And that's because they use multiple threads to process elements concurrently, and this can lead to improved performance. Are you having fun already? Yes. Okay. There are 17 more in here. So let's move to the next one. And before doing that, here I also wrote how that code will look like with parallel streams. So it is just a simple change. We could have used directly the parallel streams, and that's it. Okay, now let's move forward. And the next exercise demonstrates the use of generics in Java. We have there a box class, which is of type T. It has methods to set and get the content of our box. And in the main method, first of all, we have a string box defined with the content set to hello. And afterwards, we define another row box, set it to that string box, and then we try to set the content to 123. So in this specific example, what do you think we will get when we run this code? And I will trigger the possibility of you to submit your answer now, in a few moments. Done, I managed to do that. And you can select between A, which displays hello, B, 123. C and D are tight. First mentions that we will get an exception at row box set content 123. And D mentions that we will get an exception at line string box get content. So what do you think we will get? We will get a valid string in there, a hello. We will get that number 123 that we have set for our second example. or we will get an exception. And in the case of exception, where that exception occurs, when we are trying to set the content or when we are trying to get the content. And let's see if you, we don't have any more time. So, time's up. So B and C, these are the two options, and they have the same percentage over there, 41%. Let's see what was the right answer, and I will reveal it now. So the right answer was actually D, and only 4% of you answered that. Let's explain why. So type erasure in Java leads to row types that bypass compile type checking. So this means that assigning a row type to a generic variable allows us to set content to different types. And this happened to us. First, we were allowed to set it to a string, hello, then we could have set it to 133. The compiler doesn't say anything about that when we try to do that. But afterwards, when we are trying to retrieve the content, so the exception from line string box get content, that is where we get a class cast exception. And that's because it is expecting a string, but it gets an integer. So this is why the D was the correct answer. If we were to run this exercise, we will get an exception. I know, didn't expect that. Yes?
Is there any way to disable raw types with Java compiler?
I haven't checked. There could be. That's a very good question. Maybe we can check at the end. Thank you. And let's move to something that I consider funny. I hope you will do the same. So we have a simple string concatenation example. We have there a string results, which mentions the result is +1 +2 multiplied by 3. And we are just trying to print that result. What do you think we will get in this case? I will activate the question now. Give me just 1 second. Okay, and you can now, oh no, I have to go back, sorry. And hopefully you didn't see the response. Okay, so what would you select in here? Doesn't it work? You can't select it? No. Okay, 1 second, let's fix this. Let me get to that point. Okay, we need to go back. Give me a few seconds, something broke in here. I moved too fast, maybe some internet problems. I got to the 3rd exercise. Hopefully this won't happen for us for the 20th exercise. Okay, 4th. And let me click just once on this. Okay. Can you vote now? Yeah. Yes, perfectly. Problem fixed. All right, yes. Yes, I can share the code again for Slido. And 1 second. So you can see it on the screen now. If there are more than needs it. Solved? Good. Then let's go back to our exercise. And you have less than 10 seconds to vote over there. And I will go to the exercise back. All right. And time's up. And most of you answered correctly. So this seems to have been too simple. It is important to know that in Java, the plus operator can be used for both addition in case of integers and concatenation in case of string. And when we apply the plus operator against a string, it converts the other operands to a string as well. The expressions are evaluated from left to right. So in our case, we have here the result is a string, +1, 1 is an integer, 2 is an integer, 3 integer. These two has higher precedence because the multiplication operator has precedence over the plus operator. So this would be the first operation that is executed, 6, and then we have just string concatenation. The result is +1 +6, ending up with answer B, which was the correct answer. All right, let's move to something else now. And next we have an example that deals with mapping and nested streams. So in this specific piece of code, we are applying mapping to transform a nested collection. But there is a subtle condition within the mapping logic. We are using flat map. We are trying to convert to uppercase. So let's see what do you think we will get. And I will activate the response now. So you have less than 40 seconds already to submit your answer. What do you think that in this specific case we will get out of those nested lists from where we have started? Does that to uppercase method executes correctly or not? How does flat map works in this situation and how it affects the output that we will get? So already less than 10 seconds and we will see what was the correct answer in a few more seconds. And most of you answered correctly, 85% of you. So you correctly spotted what everything does, or everything that I have listed in here. The important part here was the flat map. This was a subtle condition that I mentioned about, because it is being used to flatten a nested collection and then to apply the mapping. So it's important to know that it converts from multiple streams into a single stream. Once again, this was too simple for you. So let's have some fun with the Java puzzle that deals with concurrency and the map. And it's actually a concurrent hash map, and there are two threads that are trying to update it concurrently. So each thread is incrementing the value associated with every key in that map from 0 to 999 by 1, but the merge method is being used. So it is important to know how the merge method actually used and what does those three parameters are supposed to do in our case. And your task now is to determine the output of the program. So no longer dealing with optimization, but rather to identify what we will get when we will run the code. We will get 1,000, 2,000, 10,000, or 20. And let's see what do you think. I'm activating the next question now. So let's see. What do you think the resulting sum of all the values in the map after both threads have completed their execution will be? And as mentioned, think of how merge method actually works. That is the important part in here, because we have two threads trying to update that concurrent hash map. And at the end, we have something to display. But what? What value? And already 5 seconds left. All right. Once again, all the answers are being selected. But again, only one is correct. And let's see which one. And time's up. Let's reveal the answer. And the right answer was B, 2000. So those of you that answered this option, you're totally right. And now let's see why. So for this specific exercise, we should reflect carefully on the atomicity of the merge method that I mentioned about, and how concurrent hash map behaves under concurrent updates. Let's look at the merge method. It has three parameters over there. The first one is the key, the second one is the value to assign to that key, and the third one, where we see here a sum, the third parameter is the method that is being applied if the key already exists. So if the key already exists, it won't apply a value of 1, it will apply that sum. And in our case, the first thread that executes with success assigns all the keys from 0 to 999 to 1. And then when the second thread comes, it will find that those keys are already there, already initialized, and it will just increment, it will make the sum from the previous value with the next value, and we will get 2. And we are trying to do the sum at the end, we will get a value of 2000. All right, let's see the next exercise, as we will stay in the same area a little bit more, then we will move to something else. But this time we will have to deal with some atomic variables, which we know already that they offer thread-safe operation for concurrent programming. And once again, we need to identify what this specific code does. And I will activate the response now. Okay, you can submit. So once again, we have there two threads that are trying to apply the method increment and get on that count. it is initially initialized to a value of 0, and at the end we are trying to see the value of that count. So what do you think we will get in this case? We will end up with a value as 0 as we initialize it, or perhaps we will get 2, 1, or an error. Maybe it's something in this code that will lead us to an error. And 3 more seconds, and we will see which was the correct answer. But most of you answered correctly because the correct answer was A. We will get 2 with the same principles as in the previous exercise. It applies the same. Both threads will execute correctly. The first one will apply 1, the second one will increment it to 2. And that's because atomic integer that we have used in this example allows thread-safe operations such as increment and get. So we will end up with a value of 2. All right. Let's move to some newer Java functionalities. And sorry, I already activated the timer. So you can start adding your response every time. In this example, we are dealing with sealed classes and nested sealed classes. And while you submit your answer, let me explain a little bit what to look at. So we have a shape class that permits circle and rectangle. In the left side, we also have an interface drawable, which permits circle and rectangle, but be careful that both of them are nested classes, nested sealed classes, defined over here. And in main, we have a shape instance, and we are trying to a circle instance, sorry, and we are trying to see if it is an instance of drawable. So what do you think we will get in this specific case? And you already submitted the answers. That was too fast. And most of you actually spotted correctly that we will get a compilation error. Hope that my ID didn't point exactly to where. But yes, the right answer is A. We will get a compilation error. And that's because drawable permits indeed circle and rectangle, but is not permitted to be implemented outside of its permitted classes, and those are nested. So in this case, we will get a compilation error if we were to run this code. Well done. Most of you answered correctly. Let's see another functionality, a newer functionality from Java, and that's about records. And in this specific case, we have a record named point with 2 arguments. And in main, we define point 1, point 2. They both have the same values over there. And we are trying to compare them. First of all, by using the equals method, and secondly, by using the operator for the equality. So I will activate the response now. And let's see what do you think we will get in this case. So it's important to know what we get when we define a record and what it's actually being compared in those 2 cases, when we are trying to apply the equals method and when we are doing the same by using the equality operator. So let's see what do you think. Okay, we are in between A and C. So either true for both of them, or true for the first one, false for the second one. Okay, just a few of you answered B and D. In the top we still have C, and let's see if C was indeed the right answer, and yes it was. First of all, when we define a record, we get all those boilerplate code that we would have written ourselves when we were to define, to write an immutable class. So we get the getters, we get the constructor, we get the hash code, we get the equals method to string, so we get all of them. So equals is already there automatically, and it compares the content of those 2 records that we are providing as arguments. So in the first case, when we apply equals on point 1 and point 2, that's definitely a true. For the second one, when we are using the equality operator, that compares references, and there are 2 different instances over there. So obviously we will get false. Okay, let's move to something else. And we have a simple list of example. So here it is important to know what exactly does list of, what it produces. And in this specific code snippet, we have a list of 3 strings, 1, 2, and 3. And we are trying to add another one, 4. And my question is what we are going to get when we are going to run this code. And please submit your responses now. So everything is there, you can submit. As options, first of all, we can get an unsupported operation exception when we are trying to perform that list add operation. Secondly, we will get 4, the value that we are going to display. Or perhaps we get an error, or perhaps the answer is none of the above. Maybe something else happens when we are to execute the code. What do you think? And for this one, as mentioned, consider how list of creates that list and what can happen when we are trying to add a new one. All right. But once again, we have all the answers listed. And I see a lot of you answer none of the above. I'm curious, what do you think it will happen?
You don't break anything.
You don't break?
You don't break anything.
Okay. Maybe. Let's see. The time's up. So, unfortunately, for those of you that answer none of the above, the right answer was A. Because list of creates an immutable list, meaning that it cannot be modified after its creation. So when we are trying here to add another item, 4, this is when we get the unsupported operation exception. We can't, yes?
Why did they add that? Like, why did they kind of disable the compiler for this?
That's a very good question, but you do get an exception when you are to run the code. You don't get any compile time exception for this. Yes. Yes. Someone should told you that. No, don't do that. But it's a very good observation indeed. But unfortunately, this is what happens, and this is why it is important of understanding which methods creates immutable objects, which one creates mutable objects. As the same for list of, we have plenty more, array of, and many others. So it's important to understand which one does what, and what to use, when to use. Right, let's move to something else. And I don't know if I mentioned at the beginning, but we will have plenty of streams exercises. I do like them. So this one combines 2 methods from the stream API, skip and limit. Who used them so far? Okay, so I expect you to answer correctly. So what do you think this specific code will do? We have a list of integers from 1 to 10, and we are using skip and limit against a stream. What do you think it will happen? I will activate the possibility of you to provide your answer. Now it is enabled. So given these 2 operations, just a skip with a value 3 and a limit with a value 4, what do you think it will happen? How does these 2 methods from the stream API works? They can be handy sometimes in practice. At least we use them once or twice in the application. This is how I found them. And 10 seconds left. Okay. I think that more than those that raised their hand knows what these methods actually do and used them previously, because almost all of you answered correctly. The answer is indeed B. Skip removes the first 3 elements, in this case, leaving us with a list made from these numbers, from 4 to 10. And afterwards, when we are trying to apply a limit of 4, that simply cuts to the 4 elements. So we get 4, 5, 6, 7, and removes everything from the right. So we will end up with B as the correct answer in here. Okay, let's take a look at another optimization challenge, another exercise with concurrency. We have a couple of these ones as well. And this one deals with concurrency and completable futures. And I will actually let you have a look at this specific piece of code. We have those 3 futures defined in here, and we are using then combine against them. And at the end, we are trying to print the result. And the question is, what would we improve at this specific piece of code? Perhaps you would replace then combine with all of, or add an explicit executor, use then compose, maybe instead of then combine, or change join to get. this one over here. Instead of results join, maybe you can use get. So out of these 4 options, and I will activate the response in a few seconds. Done. I've done my part. It's yours now. What do you think we will get in this case? Not what we will get, sorry, what would we need to change in this specific piece of code to improve it, but to still return the same value. You don't want to break the code. So what would you choose? Replace then combine with all of, add an explicit executor, use then compose instead of then combine, or just change join to get. Or maybe there are some other options. As mentioned, I only listed a few, those that I could think of. And time's up. So most of you are in between A and D, and the right answer is A. And let's go through all of them and see why. And I should probably start with option D, because most of you selected D. And let me get back to this. So the right answer is A, but I want to have all of the options displayed, and you as well. So in this case, both join and get can be used indeed to retrieve the results from a completable future. That's correct. So we can, in theory, not even in theory, in practice, we can simply replace join with a get and get the same results. But there is a difference in how they work. In this case, join is preferred because it checks for unchecked exceptions. So from this perspective, is preferred over get for completable futures because it handles all the exceptions. So this is why I didn't consider D as a correct option, but A to replace then combine with all of, because it offers a better performance than just chaining multiple then combine options as I have listed in there. And the refactor code, let me get to that part. One more slide. It's something like this. So all of waits for all the futures to complete, but it's better than just chaining then combine. This is at least why I have considered this specific piece of code correct. But yes, D could do the same, only that it doesn't check for all the exceptions as join does. All right, let's switch to something else, and that's related to lambda expressions. So let's examine this long exercise. It's plenty of code over there, so let's look over it. We have those lambda expressions that demonstrates how to filter a list of words using multiple predicates. We have a first one over there that checks if the length is greater than 5. And the second one that checks if it starts with an A. So we have that list of strings, and we are trying to see which one is greater than 5 and which one starts with an A. And I think the code doesn't look that readable. Don't you think so? Okay, seems that you agree with me. Then what would you change over here to improve it? From a concision point of view, so how to make this code more concise, more readable. And I will activate the response now because you had some time to look over the responses already. First of all means to refactor filter words, so this very long method, to use some stream API and combine the predicates using the AND. Or perhaps we can use inline predicate combination in main directly. Or C mentions that we can use it as it is, but I think we all agree that C is not an option, so please don't select that one. And D mentions to replace predicate with some custom functional interfaces, and mentions here that maybe it will provide some better performance. So what do you think it will be the answer in this case? What would you select? And time's up. Okay. The timer is faster than me. The right answer is A. So those of you, 81% of you, you thought the same as me. And yes, we should refactor that filter words method to use stream API. And I think I have an example over here. It can look like this, which is much better. Isn't it right? Cool. Okay, let's look at something else. We have a simple map exercise in here, where we are trying to add some key values, but it is important here to try to conserve the original key values to avoid some duplicates or to avoid having our options being overwritten. So first adds a John Doe, Jane Doe, and the third one wants to add John Smith, or to replace my previous insertion in this case. So what would you change in this specific exercise to ensure that we keep the original key values? And I will trigger the question now, so you can submit your answer. And we have there a first option, to use put if absent. Second option, to modify the map to use a linked hash map instead, or keep it as it is. Maybe it already doesn't override my previous key value assignment, or use a tree map with a custom comparator to handle those duplicate keys. So out of these 4 options, 10 seconds left, what would you choose? Let's see, a few more seconds, and time's up. Let's reveal the correct answer. We can use put if absent. And from what I see, most of you answered this option, but most of you also answered to use a linked hash map. All right, let's see. Put if absent definitely ensures that the existing key values pair is not overwritten when the key already exists. So this will do what I was asking about. It will prevent duplicates from being inserted. It will ensure that we keep the original key values in our map. If you were to look at the others, and I will once again go back to them. So most of you answered the linked hash map, B. This preserves the insertion order, but doesn't directly address the problem with the duplicate keys, so I wouldn't use this one. And I will also mention about D. I'm not going to say that C was an option in there. We definitely don't have to keep the code as it is, but for D, to use a tree map, that's definitely helpful with the sorting part, but doesn't address at all the problem with the duplicate. So we'll end up here just with option A, to use put if absent. Let's see what else I have over here. I will actually display how the code will look like. We can use put if absent everywhere, or just where was the problem. I used as an example just there. And the next exercise, we have a virtual thread challenge. So the following code that we are currently looking at uses traditional threads for concurrent execution. It actually creates 1,000 threads to run concurrent tasks. How can you improve this specific piece of code? And I will activate the question now. And as options, we have there the possibility of using new virtual thread per task executor. This is something that was introduced, if I remember correctly, in Java 18. We can use Completable future for asynchronous tasks, or perhaps we can use a cached thread pool instead of a fixed thread pool, or use fork join pool for parallel execution. So out of these 4 examples over here, what would you choose to improve how those 1,000 traditional threads are trying to run a concurrent task over there?
Are the tasks IO bound or CPU bound?
CPU bound. And I think time's up. And once again, most of you answered correctly. The answer is A. I will activate this one. And yes, we can use new virtual thread per task executor. As mentioned, I think it was introduced in Java 18, so it's something pretty new. And it creates an executor that generates automatically a task for a thread for each task that is being submitted to it. So this is why it is definitely improving those 1,000 threads that we would have in my previous example. And we can also look over here on how this would have looked like. is just calling that method, and that's it. It's pretty useful and definitely provides a better performance. And let's deal with some randomness now. So let's switch context to something else. Have you worked with random classes before? I guess, I hope, all of you. Each of us have at least used once a random class, and here it's a simple random class that generates some random numbers. How would you optimize this? And I will trigger the question now. One more second, and that's it. So, would you use a thread local random instead of random? So we want to replace this one, but how? Use thread local random, splittable random, random generator factory, or secure random. Out of these four, what would you choose? And 20 more seconds. Okay, all the answers are being selected. Most of you you like to use a secure random. Let's see if that's the right answer. A few more seconds and we will see what was the right answer. And time's up now. So let's see. The correct answer was actually C. And only 25% of you selected this one. We will definitely discuss about that secure random as well. Indeed, it's best in certain scenarios, but not for our specific scenario because it is slower than other random generators. The correct answer is, as mentioned, the random generator factory that is introduced in later Java versions, I think 17 if I remember correctly. And it allows the possibility of selecting the best available random generator for specific requirements, as we have here in our example. The others, as I saw, you selected all of them. Thread local random, that provides indeed a better performance, but only in multi-threaded environments. And it's not our case in this simple example of generating some random numbers. And the second one, option B, and I'm looking at the answers, you are not, I fixed this now. The second answer was to use a splittable random. This is also better in specific scenarios, but that's mostly regarding to parallel streams execution. And once again, it's not our case over here. So the option from JDK 17 is definitely better for us to use that random generator factor, which allows itself to select what is needed. All right, we have 3 more exercises and 2 minutes. Let's see if we can finish this one. The next one deals with optionals, and I will already trigger the possibility of you to submit answers. So this one deals with some nested optionals, and the answer is, what would you change over here? Just to deal with some nested optionals, we have the possibility of using nested if checks, we have the possibility of using flat map, or else, or use a try-catch block. What would you select in this specific case? Just to improve this specific code that deals with nested optionals. And a few more seconds, 5 seconds left. All right, and let's reveal the right answer now. Most of you answered C, optional or else. I'm afraid that doesn't handle nested optionals. And neither try-catch. Try-catch is not suitable for handling optionals. I saw that a few selected this one as well. Nested if checks are too verbose, less readable, but a flat map, as we have already seen for the nested collection, does its thing and flatten those optionals. All right, let's see some streams, and we will finish after them. And I will once again activate the trigger so that we can finish on time. So next exercise, we have a stream challenge over here. Also to improve a specific piece of code. This one computes average and the sum of a list, but both of them separately. And we would like to improve the performance of this specific piece of code that handles with string. We only have 5 numbers from 1 to 5 and less than 20 seconds to see what was the correct answer. Maybe use 2 separate stream operations, maybe use collectors, teeing, something interesting over here, or parallel streams, or just a for each loop. And in 6 seconds, we will see what was the right answer. We are in between B and C, either to use collector sting or to use parallel streams. So let's see, let's reveal the answer. And the correct one was to use the collector sting, because this one allows the possibility of computing both the average and the sum of the list of numbers that we have there in a single stream operation. So this does exactly what I mentioned previously. And the last one, and we will finish, also streams. As mentioned at the beginning, I have plenty of stream exercises. I will activate the question now. Once again, and the last one for today, what would you think that we need to change over here? We have this code that processes a list of integers up to a certain point. The limit is 5 in our case. And we do want to stop after 5. We don't want to go through all the elements. So would you use a for loop? Would you use stream filter, stream take while, or just stream limit? Out of these examples, what you do choose? And already less than 3 seconds, and we will see the final result for today. And the right answer is C. Use take while from the stream API. And I will reveal the answer on the application as well, and the leaderboard, so you can see now what you have done, each of you, while I explain why take while was the right answer. It was in between filter and take while from what I saw in those examples over there, but there is a difference. If we apply filter, that doesn't stop when it meets a value of 5. So it continues to process all the elements from 5 to 10, despite the limit that we have. The option that I mentioned in here, take while, well, it stops. When it meets that value, that is a limit, it stops processing all the other elements, making it the right answer. And I think the time's definitely finished. So I would like to thank you all for your active participation. Your engagement truly made our session productive. Hope you had some fun and enjoy the rest of the day. If there are questions, I'll be around here as time's up and the next speaker needs to prepare for today. So thank you very much and have a good day ahead.